Hi my dear students, this is Hazarath Kshatriya from IIT Kanpur. Welcome back to interview guidance session. Let us discuss a very interesting question which is asked in Park. That interviewer gave one situation, that is a bus accident happened on Tirumala Ghat road. Here bus is moving slowly in downward direction. In that situation, Dhanush came in the helicopter and Rajinikanth is walking on inclined Tirumala Ghat road in this particular direction. Rajinikanth saw the situation, then immediately he reacted that he thrown a thread which is passing through the pulley which is connected to helicopter. One end of the thread, a hook is connected. Hook catches the bus. Then Rajinikanth moving on the inclined Ghat road in downward direction. This is the situation. He asked you to draw free body diagram for the total system. Finally, determine power of the Rajinikanth. Now, we need to build a schematic diagram for the given system. See here, Rajinikanth is on inclined Tirumala Ghat road. He is moving down. Bus is here. He has thrown the thread which is passing to the pulley. It is connected to the helicopter. Your hook is here. Hook is here. Thread. It catches the bus. Finally, bus is moving in upward direction. Rajinikanth is moving in downward direction with the same acceleration here. Acceleration of the bus equals to acceleration of the Rajinikanth. Now, this is schematic diagram for the system. Now, we need to draw free body diagram for the system. System contains Rajinikanth, pulley and bus. First, focus on drawing free body diagram for the pulley. Here, pulley is rotating in this particular direction. This particular thing is tight side. This is slack side. Okay. Tight side tension T1, slack side tension will be T2. Tension always pull the body. Inertia torque always at opposite to the direction of rotary motion of the body. That is, this is the direction of inertia torque. T1 tight side tension, T2 slack side tension. Here it is friction pulley. That is why T1 by T2 equals to e power mu theta. Here mu is rolling friction, theta is lap angle. Okay? So you will get the relationship between T1 and T2 from here. This is all about free body diagram for pulley. Now focus on free body diagram for Rajinikanth. Weight of the Rajinikanth always at vertically downward direction. Next, at every point of contact, two normal reactions will be acting. Both are equal in magnitude and unlike in nature. One normal reaction acting on Rajinikanth, another normal reaction acting on inclined Ghat road. Next, tension always pull the body. T2, corresponding tension is T2. T2 is slack side tension. Now, inertia force and frictional resistance both always act opposite to the direction of motion of the body. I incorporated all the forces which are acting on Rajinikanth. Now, we need to focus on free body diagram for the bus. First, weight of the bus including passengers always act vertically downward direction. Next, tension always pull the body. We need to take corresponding tension, that is tight side tension. Next, inertia force always act opposite to the direction of motion of the body. Okay, so that will be downward direction. After that, air resistance is neglected. That is why you no need to take frictional resistance here. This is all about free body diagram for the bus, pulley and Rajinikanth. This is the way to draw free body diagram for the total system. Now we need to determine the magnitude of power of Rajinikanth. For that we need to apply dynamics. Okay, see free body diagram for Rajinikanth. We know that it is theta. Here resolve the forces. W or sin theta. Here it is W or cos theta. Now sigma fx is nothing but the magnitude of net force acting on Rajinikanth in the direction of motion of him. Okay, so we need to consider all the forces which are acting on Rajinikanth in the direction of motion of it. See here, that is nothing but W sin theta in the direction of motion is positive minus tension T2 opposite to the direction of motion is negative. After that, see here, F inertia Rajinikanth minus frictional resistance. This is magnitude of net force acting on the Rajinikanth in the direction of motion of him. Okay. Now, what is power of Rajinikanth? Equivalent to sigma Fx into velocity of the Rajinikanth. This is power of Rajinikanth. X means in the direction of motion. Okay. So this is all about drawing schematic diagram for the system, free body diagram for the system, finally applying dynamics to determine the magnitude of power of Rajinikanth. Okay, now interviewer interested to check student knowledge in 3 ways in this particular question. That is, whether the student is in position to draw a schematic diagram for given narrated system. Okay, now he gave one situation. For that you need to draw a schematic diagram. Whether the student is in position to draw schematic diagram. Next, student is having knowledge in drawing free body diagram. Finally, whether he is able to apply dynamics to determine the magnitude of power of Rajinikanth. Okay, these are the main objectives of asking this question in part interview. Okay, thank you.